Hello mathematicians. Today we are going to start looking at trigonometry. Trigonometry is going to compare the angles and sides of a right triangle. So there are three types of trig functions we are going to use if we have a right triangle. Sine, cosine, and tangent. Sine compares the opposite side to the hypotenuse. So for example, if I was starting with sine of angle A, I would find angle A, and I would need to compare the opposite side. So the opposite would be A over the hypotenuse, and the hypotenuse is always across from the right angle, C. So A over C, or whatever those values would be. So you find the angle that it's talking about, and you go opposite over whatever the hypotenuse is. Cosine compares adjacent to hypotenuse. Adjacent means the one that's next to it, but not the hypotenuse itself. So cosine of A, so I'm going to start with the same angle. Cosine, it's not opposite, and it's not the hypotenuse. So B must be the adjacent. It's the one next to it that's not the hypotenuse. This one's the hypotenuse. So it must be B over hypotenuse C. Lastly is tangent. Tangent is opposite over adjacent. It compares the opposite to the adjacent side. So if I start with A, we said the adjacent was the one that was next to it, so B over the hypotenuse, not the hypotenuse, sorry. I want opposite, which is A over adjacent B. So you've started the angle and you're going to go opposite, hypotenuse, or adjacent. One way to remember this is SOHCAHTOA. SOHCAHTOA. And this sets it up for you. So is sine, opposite over hypotenuse. And it puts it right in over. Sine is opposite over hypotenuse. Cosine is the ca part, and that would be A stands for adjacent over hypotenuse. And TOA stands for tangent, which would be opposite over adjacent. So three trig functions. Find the angle it's talking about, and you're either looking for sine opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. SOHCAHTOA. Help you remember those trig functions. So if I look at my trig functions for A, I'm going to start at angle A. Remember our SOHCAHTOA. Sine is opposite over hypotenuse. So opposite of A is 5. And which one is the hypotenuse always going to be? 13 is always the hypotenuse. Why is 13 always going to be the hypotenuse? It's across from the right angle. So 5 over 13. That's it. Cosine of A now. Again, I'm going to start at A, but cosine is what? Adjacent over hypotenuse. Well, 5 was opposite, 13 was hypotenuse, so what one has to be adjacent? 12. It's the one next to it, but not the hypotenuse. And the hypotenuse is still 13. Lastly, we have tangent of A. And which pieces do we need for tangent? TOA or opposite over adjacent. So starting at A, which one is opposite? 5. And which one is adjacent? 12. 5 over 12 gives us our tangent. Go ahead, and this time we're going to look at angle C. So I'm going to start at this corner when I do it. So you need to start here to find the opposite, adjacent, and hypotenuse. Try those ones. Let's see how you did. Sine C, what are the two pieces we need to know for sine? So, or opposite over hypotenuse. Starting at angle C, which one is opposite? 12. And which one is always the hypotenuse in this triangle? 13. Cosine then. What do you need to know for cosine? Adjacent over hypotenuse. And starting at C, which one would be adjacent? 5. It's next to it. The other one besides the hypotenuse that's next to it. So the hypotenuse is 13. 5 over 13. And lastly, what did you need to know for tangent? Opposite over adjacent. Opposite was 12. Adjacent is 5. SOHCAHTOA. Sine, cosine, and tangent. Use those trig functions to help you. Take a look at this one. If I want to set these up again, what did we use to help us remember the order? SOHCAHTOA. So sine of W, I'm going to start at W. And sine, what do I need to know? Opposite over hypotenuse. Starting at W, which one is opposite? 12. And do we know the hypotenuse? No. So we need to use what to find a missing side? Pythagorean theorem. I need to figure out what this missing side is. So 9 squared plus 12 squared equals our hypotenuse squared. Go ahead and solve for x. 9 squared plus 12 squared, 225. And when you solve for x, square root both sides, x equals 15. So that hypotenuse that we were missing was 15. This time, we need to simplify 12 and 15. I can divide them both by 3. And that should be 4/5. So simplify. Now that I know that hypotenuse, I'm in good shape because I can figure out these other ones without having to do any Pythagorean theorem. Cosine, what do you need to know for cosine? Adjacent over hypotenuse. So starting at W, which one is adjacent? It can't be 15 because 15 is the hypotenuse. So it must be 9. And the hypotenuse is 15. Divide them both by 3. You get 3/5. And lastly, tangent is TOA. And what do we need to know for tangent? Opposite over adjacent. Starting at W, which one is opposite? 12. And which one is adjacent? 9. Divide those both by 3 and we get 4/3. Now this time let's look at angle X. I'm going to find sine of angle X. So I'm going to start in this corner of the triangle. Find these 3 trig functions for angle X. Let's see how you did. Sine, what do you need to know for sine? opposite over hypotenuse. Starting at x, 9 is opposite. And what is the hypotenuse? 15. This simplifies down to 3/5. Cosine. What do you need to know for cosine? Adjacent over hypotenuse. Starting at x, which one is adjacent? 12. And which one is hypotenuse? 15. Divide these both by 3 and we get 4/5. And lastly, TOA, or tangent, we need opposite over adjacent. Opposite is 9. Adjacent is 12. Divide those both by 3 and we get 3/4. So make sure you use SOHCAHTOA to help you remember the two pieces that you need for each trig function. Nice job, mathematicians.